Are you the host? Okay, cool. Sweet. So yeah, just wanted to show you guys. I know Maverick was wanting me to give like a little bit of a overview of how the architecture. Um, and I know you guys are doing bug bounty stuff, mostly on the, it seems like the extension side of things or web IDE side of things. Is that correct? For sure. Okay, cool. Um, so I can kind of give you guys, I was thinking about breaking it down into two sections, one being Duo Chat and how Duo Chat works, and then the second one being how our language server works. Because it's kind of like language server is a little bit more complex than Duo Chat. And there's some like, I guess, prerequisite knowledge that you need to know about, right? So I'll pull up this little, it's called Excalidraw. If you guys ever want to do any like quick note taking or like diagramming on, how this stuff works, or how like you want to make any designs, I think it's a really good app. So let me share my screen. I don't know if it's gonna ask for me to request or can you guys see my screen? Awesome. So, yeah, so I have this little Excalidraw app open here. And we'll go into these little diagrams in a moment, but I wanted to start off with a little bit higher level on how things work. So, and please let me know if you guys already know this, but I think it's important to know how a lot of these things kind of work under the hood, right? Especially if you're going to start solving bugs and doing stuff on them. So let's start with like the basic of the basic, and that's Duo Chat in the editor extension, right? And this also applies to like the Web IE to an extent. There are two different runtimes, of course, but um, I still think it's pretty much translatable knowledge, so long as you understand how these architectural components play together. So we have VS Code. So let's just start with VS Code. So when you launch the web IDE, this is a over dramatic simplification, or you launch the desktop app, we have VS Code. So let's put it in. Let me zoom in because I think it's supposed to be like a little bit smaller. Let me make some quick text. Cool. All right, we'll change it to large for now. And let me know if this text is good for you guys. Maybe we should use the code one to be fancy. Cool. Um, awesome. So we have the VS Code app here. And this VS Code app is built. Do you guys know what it's built in? And it's not a gotcha question. You might not even have looked that up. But do you guys know what like the runtime is? This is actually all of this is built in. Yes, no, maybe so. Any guesses? No. So for desktop apps, so actually the reason why VS Code works in both the browser and desktop apps is because it's built in this technology called Electron. So if I pull up, can you guys still see my screen? Cool. I don't know why it's being weird. If I try to like make a new tab, it doesn't do anything. So there's this runtime called Electron. I don't even really know if it's considered a runtime, um, but it's really a combination of the Node.js runtime with the some of the basic JavaScript runtime that comes with like V8, for instance. So these are really important concepts to know when and you'll probably be using these technologies or seeing these technologies throughout your career. So the more you know about like Electron and V8 specifically, like what is V8 and what is Electron, and then what is Node.js. Those three things are really powerful concepts to know, because then once you understand how these lower level building blocks at least what they are, and I'll give you a brief overview of what they are. Once you know these little bit of foundational technologies, you can see how things like VS Code are built. So just as a quick rundown, when you write some JavaScript code, so if I write, like, for instance, sorry, I'm used to a different keyboard, so I'll be making mistakes. It's like completely different layout than I'm used to. So if you, let's say we just do function foo, right? Let's do simple function. Sorry, I cannot type today. Foo. And we, I don't know, do a little console log. Actually, we declare a variable. Let's do some new class, right? So const, we made a new class called, like a class called hello world, right? Hey, Dylan. Yeah, hello world. And this is our class here, hello world. And we create a new class like this, hello world, just like that. As you guys have seen in the JavaScript world. So this class here, what happens is when you write this code, right? And this is a super high level overview. This is not like a lot of how, like, exactly how it works under the hood. But when you write this JavaScript code, and it depends on the runtime, but it mostly is the same for Node.js and the browser. So your code will be sent essentially over to what's called the V8 engine. And Node.js works a little bit different. Do you guys know what Node.js is? Let me know if you do or do not. You might not know. Okay, cool, sweet. It's good that you guys don't know, because it's good, like, it's just good to see how it all works. So there are two different things. So there's the browser. So we'll make this little square here. We'll call it the browser. So this is like what you go and download, right? And you want to go, I don't know, play some online games, or you want to view a website. You have the browser. And this uses what's called V8 under the hood to power it. And V8 is a JavaScript engine. So we'll write here, JavaScript engine. And we also have another runtime, and this is a server runtime. And let me know if you guys don't know what I mean when I say server. We can go over that as well. But Node.js is a server runtime. So we'll put in parentheses here, server runtime, right? Just like this. So we have Node.js, which is a server runtime. This also uses V8 under the hood. And that's a JavaScript engine as well. It's pretty much the exact same thing. And so when you write your JavaScript, so like when you go and, for instance, I know London's going and fixing like a slash command, right? And she's changing some of the code in there. When she changes that code, this is a dramatic oversimplification. I don't want to make it too complex right now, but when she goes and writes that code, whenever we compile it, and that's a whole another can of worms, but essentially you have at the end of the day JavaScript just like this. So if you write raw JavaScript, like, you know, myfile.js, right? When you tell Node or the browser to run your JavaScript, and maybe I should have pulled up like practical examples. What's happening is what this is doing is this is taking your code that you wrote and running it running it through what's called a JIT, or just-in-time compiler. And so it's basically, you can think of it as a real-time compiler that reads your code and does lower level operations under the hood. So you can see here we made this little call here to this class hello world. And what's happening is this is sending this code to a JIT, just-in-time compiler, and it's telling the V8 engine specifically, or the V8 engine does this as part of the logic that it does. It basically tells the computer to allocate some memory, and you guys probably see this in your classes and whatnot. It tells your computer itself to allocate some memory for this object, either on the stack or the heap. And whether or not it goes on the stack or the heap is totally up to how the business logic of the V8 engine does it. But all you really need to know for now is at least is it allocates memory on your machine. So we'll just put it like this. So this variable lives on your machine somewhere, but it's not living like in the JavaScript sense. It's actually translated to C++ code at the end of the day. And that's C++. I don't know if you guys have used C++. Who has? Raise your hand if you haven't, or anything like that. No? Totally cool if not. So basically it turns into other code, which gets, I think Dylan raised his hand. It gets turned into other code, which then eventually makes it down to your machine to where this data essentially is on your machine in a byte address, either on the heap or the stack, right? And this is important to know because when I say V8 and when I say Node.js or the browser, now you can know these terms, right? Because without knowing these terms, it's much harder to piece together the architecture of the VS Code and Duo Chat and all those things. So I don't know if you guys want to take a screenshot of this, and I can definitely link some like references to these technologies, but these are like two foundational technologies. If you know them in and out, like you really can translate these skills to really a ton of different applications, not just like Duo Chat and VS Code and whatnot. So am I making sense so far? Any questions? Let me know. And feel free to ask any questions. Like it's totally okay. I'm not trying to make this into like a lecture. I'm trying to hopefully drive the point of the overall architecture, but I think these are like foundational things to know about. And it's totally cool if you don't. Like I had no clue all this existed anyways. And the neat thing to know about all this whole process is there's thousands of developers working on each one of these components. So like V8 has a dedicated team at Google and a ton of external contributors who go into the V8 engine. So if you go up and look up V8 JavaScript engine, just like that here, this v8.dev website, they have a whole blog and they have a whole community that's maintaining this whole engine. And the V8 engine, like I said, is responsible for turning this code into basically memory on your machine. That's what the V8 engine is. So you can think of it as like a brain that sees code and takes your code and does fancy things. Like if you write, for instance, under this, like I reassign hello world. Let's turn this into a let, and I reassign this hello world into, I don't know, something else. Hello world, we'll do is equal to, I don't know, hi London, like this. Sorry, I'm used to the other keyboard. Oh, whoops. Hi London, like that. So when this gets reassigned, what the JavaScript engine will do is say, hey, we saw that like, this object was declared and we put this on probably the heap, maybe the stack because it's in just this one function closure. But then it sees this and it says, oh, wait, it got reassigned to this string here. So maybe let's put it on the stack so that, it ends up on, so it can be manipulated a lot quicker. But a lot of that logic that I just talked about is handled in the JavaScript engine side of things. And so what does the browser and Node.js do? These are really important concepts as well. So Node.js is a server runtime. So when you think of this, think HTTP. Have you guys, I'm assuming you guys have heard that, HTTP, right? So you think HTTP, think WebSockets, as is another example. What else is there? Dylan, let me know if I'm forgetting things. But oh, CLIs. So a lot of CLIs are written in them. Scripting is run in Node. You can think of this as a server runtime that's supposed to be run on a machine, maybe like a Linux server or a MacBook even. So like I would pull up an example. I can pull up one now. Let me create a new window. And let me make this bigger here. And I'll go to my Node playground. Like this. And we'll go into this here. And we'll make a new file. We'll call it let's just delete all this code here as an example. So I have a little playground folder here, and we do, console log, I don't know, hello Derek as an example, right? And we'll save this, and then we'll go back to the terminal and run it. So npm run watch. It's the same thing as running it, and you can see it does console log hello Derek. There's also a thing where you can do like where you actually create like an HTTP server. So you like hit an endpoint. I think it's Node's HTTP module. So maybe we can get AI to write it for us. I don't know. Start HTTP server. Yeah, something like this. My completions are not working. But it'd be something like this. Let me go here. And I don't know. I think it's like const. Yeah, something like, require HTTP, and then you start your server, and then it creates like some endpoints. We could even use probably like DuoChat to give us an example. That's actually probably a faster example. Let me pull up the VS Code extension. Okay, cool. So we'll pull up this as an example. Let me clear this. And we say, give me a node. Oops. Give me a node. You can read this, guys, right? Hopefully. HTTP server. It should hopefully give us something pretty basic. Get rid of this code so you're not confused. Get rid of this. Cool. So you can see here it does like, let's zoom in a little bit more so you can see that better. We have, HTTP create server, and then you set like an endpoint. I'm sure you guys have heard of the word endpoint, right? So going back to our little chart, let's go back to this little chart here. When you write that code, what's happening is it's telling Node to import that code. And then Node.js has specific code itself for setting up those HTTP related things. So when you think of like browser stuff, right, you're thinking, using the user's keyboard or rendering some HTML and CSS, versus Node.js is more like creating endpoints or creating CLIs and stuff like that. So they're two distinct things, and knowing the difference between them is like super important, super crucial for the stack that we work on every day. Dylan and I work on every day. Dylan's more on the JetBrains side, which uses the Java virtual machine under the hood. That's a whole other can of worms. But really, what you should a good thing to know is the difference between Node.js and the browser. And really, just the main difference when you think of these things is just think Node.js is server and browser is rendering things like HTML and manipulating this thing called the DOM. Have you guys heard of the DOM before at all? Okay, cool. Yeah, so usually you'll write JavaScript to manipulate the DOM. So if you wanted to, for instance, like, hey, put this button here, or when a user clicks this button, call a server and get some data back, right? That's all done in the browser, and that's done through JavaScript. So when you write JavaScript and it's run in the browser, it gets run in the same V8 engine, but the browser exposes this browser-specific APIs, like what's an example? Dylan, can you think of anything on the top of your head? It's been a minute for me. Maybe
Say that one more
like,
time.
what'd you say?
Say that one more time.
Any examples of like browser specific APIs? I'm trying to think. Like uh, if you go to Mozilla as an example, because they maintain stuff like that.
I mean, is CSS count?
What'd you say?
Does CSS count?
Yeah, you can whatever JavaScript that modifies like DOM CSS. I think that probably is an example. Um, if you even just type in here, we type in DOM, we can probably find all the um, different things. So we have there's get user metadata. This is an example, which gets your stuff like that. Geolocation API. So these browser specific APIs, like the user clicked on something, or have you ever, like, as an example, location, like whenever you're surfing the web and it says the browser wants to know your location, that's a browser API, as an example. And so the browser exposes those APIs. So, user interaction APIs. Um, cool. So I know it's definitely a lot to ingest. It's probably like 3 different, I don't know, courses in one. But once you understand this, now you can understand the DuoChat and language server architecture. So this is kind of like the under the hood architecture of, when you write your code that you're, going and doing these bug bounties on, this is like kind of the process that happens as you build your code and you make changes and you push up a MR and it's running the whole pipeline. It's doing a lot of the stuff that you see here for all the code that you write. And then from there, so any questions so far on that? I know it's a lot, so feel free to ask anything. Nothing? Going once, going twice? Cool. Okay. So the next thing that you're going to want to know is VS Code. So VS Code uses this thing called Electron under the hood. So Electron, actually, to complicate things a little bit more, so these two things here, I don't know what's a good way of not making this seem crazy complicated, but if we go like this, we'll put these 2 arrows here. That looks kind of ugly, but I guess you guys get the point. So when you combine both of these things, you get Electron. So Electron is a runtime, kind of like a runtime. It's really a Node.js runtime with the browser kind of embedded based on, my understanding of it. But it's a specific technology that enables desktop apps. Because what happens is if you have like another desktop app, what's an example? Some examples of like desktop apps that you can think of is like Slack, if you guys have the Slack app on your machine, or um, a difference between something like an Electron app and another app would be like the iMessage app. Have you guys used? I'm sure you've used iMessage on your computer, right? So iMessage is most likely written in Swift, and Swift gets compiled down to native bytecode, versus Electron is using JavaScript code and rendering some HTML and CSS, but it renders it's able to be run in an isolated way to where it uses your GPUs and renders the app on your screen just like a regular web app. So if I go to what's an example? I'm sure there's like a showcase here of famous Electron apps. I guess a great example would be maybe I'm trying to think. What's a good example? Um, Maybe like Spotify. So if you ever pull up Spotify on your computer and it has like a desktop app, and then you go to the website Spotify, it looks like basically the same thing. It's most likely because it's written in Electron and it's sharing a lot of that same JavaScript code, if that makes sense. So then when you think of the web IDE, that means essentially the reason why like the GitLab web IDE is able to be launched in the web is because and also like VS Code on your computer, just like this, and you get to use it in both places, is because it's using this technology here that renders the code in basically the same way, and allows you to run your code on the browser and then also on the desktop because it's running JavaScript at the end of the day. So if you're ever wondering, like, how does Spotify have the same app on the desktop and then in the browser, or how does all the different types of apps, maybe Shazam as an example. There's a bunch of other apps, Notion, maybe. Um, I'm trying to think. There's like a ton of popular apps out there. So Electron's definitely a pretty popular platform. So once you understand Electron and you know that it uses both Node.js and the browser DOM under the hood, you basically know how VS Code works, because VS Code is built on Electron. So if you go to the actual VS Code repository, where is it? GitHub, right here. And you see that it's written in TypeScript, which is basically JavaScript at the end of the day. And you go to package JSON, you'll probably see here, somewhere in here, Electron. And you can see, yeah, it's using Electron. So if you go to so this is the source code for VS Code. So when you're opening up the VS Code editor and you're making changes, a lot of the code is run by the same code in here, and it's written in JavaScript. So does that kind of hopefully demystify things a little bit for you guys? I don't know. Let me know if it's not, like if it sounds like super crazy. Cool. Yeah, so VS Code runs Electron under the hood. And this is important to know because now that you know that it uses Electron, you know that how it's able to run the code that you write both on the browser in the GitLab web IDE and on the desktop. So actually, if you go here, and this is now getting into the GitLab specific things now that you have the foundational knowledge. So when you go to the left here, and we have this extension called GitLab Workflow. Find it, workflow. So you have GitLab Workflow here. So this GitLab workflow extension is like the name is an extension of VS Code. And so it's another set of JavaScript code. So we'll go over here and we have the GitLab workflow extension. Let's make, that should be good. Whoops, workflow extension. Cool. So when you're going to modify Duo Chat and, let's see, Duo Chat, code suggestions, Workflow does other things like allowing you to see your open MRs as an example. So we have VS Code, Electron, and then we have the GitLab workflow extension. And Duo Chat lives in this extension. So we'll put out two branches here. And we'll put Duo Chat here. And then we can break down some of the technologies that are in there as well. We have Duo Chat, and then we also have code suggestions. And code suggestions uses something else under the hood. And we'll get to that if we have some time. Maybe we can do a part 2 if you guys want to do a part 2 so you can digest this diagram, which seems kind of like a lot. But we have VS Code, and it uses Electron under the hood. And so then it exposes these APIs like extension dot activate. So if you look for activate in the GitLab workflow code base, so if you look up like VS Code extension, if you go to this website here and you look at this GitLab VS Code extension repo, you'll see something in here like, activate. And so what this is doing is VS Code is looking at all of your different extensions and then running the activation, API across all of the different extensions. And then we have this GitLab workflow extension, of course, that's registered when you install it. And then that workflow extension bundles two different things, multiple things, but the two major things that you guys are probably working on, which is Duo Chat and code suggestions. So does that make sense so far? It seems kind of abstract, but I think hopefully it'll make sense that you realize it's all using kind of the same thing under the hood, which is just, Node.js and the JavaScript engine. Because because VS Code is written in, JavaScript, that essentially the workflow. So for instance, like a practical example is London's going to, and you guys let me know if there's other things that you're doing as well. That's the only thing I'm aware of, but London's going and changing like the slash command in VS Code here, right? Where I think there's some bug in Duo Chat that like, in here, she wants to remove, I think it's the clean command, right? As an example, where there's some bug where I think clean exists and actually cleans it, but that shouldn't exist because it doesn't show up in the menu, right? So all of that code is written in the GitLab workflow extension. It's basically the GitLab VS Code extension, the name of it. And it's also a web app. So let's break down how Duo Chat works a little bit further. So Duo Chat is a web app. And how does this work? So The reason why, like for instance, you go to gitlab.com, and this is pretty cool because once you realize like how these things work, it kind of ruins the magic of the internet for you because now you know how everything works. So then you get frustrated by like, things that don't work. But it's also cool to just know how these things work. So like when I open GitLab Duo chat here and it looks roughly the same, right, as this here, that's because it's actually using a lot of the same code, which is JavaScript. So if I go back to our little thing here, we made this thing called the GitLab UI package. So definitely look this up if you guys want to know what this is. So there's a little npm package that is shared code basically at the end of the day. And this GitLab UI is used as the main way of displaying Duo chat. And then the difference between GitLab.com and the VS Code extension is that when I press enter, right? So when I go here, and I'll pull up the logs as an example. Let's go up to the GitLab workflow logs. And I say, how do I clone a repository? You can see it's doing, like it's making some logs here, fetching to an account. You can see it's fetching, and then looks like it's finished. So you can see here finish, and all the requests were successful. So what's happening here is the GitLab UI, like the CSS, so we'll write this here. The GitLab UI handles a lot of the CSS, HTML, maybe like user interactivity. And a few other things that I'm probably forgetting. So like a button, when you see a button on Duo Chat, or you see, I'm trying to think of another example, like all of the text here that's rendered, and you see this nice formatting here, and this being able to click links, and then this interactivity where I type and it's like a chat, and all of the selection here. That is logic that's located in the GitLab UI. So when you think of interactivity with the actual UI, think GitLab UI. And GitLab UI is built with this technology called Vue. And if you haven't heard of Vue, that's totally okay. When you think of Vue, you can really just think React. They're not the same thing, so it's an important distinction. But they're both front-end technologies that allow for user interactivity, basically. So it's built in this thing called Vue, in this technology called Vue. But at the end of the day, it's just a fancy way of letting the user interact with the UI, right? So then whenever I made those API calls, so you guys remember the log that you saw there, what's happening is the user presses the button or they press enter and it gets submitted. What happens is the GitLab UI makes an API call back to the extension, and it communicates through this thing called the VS Code web view API. So without like making it without hopefully confusing you guys too much, just think that DuoChat is a embedded web application. So we'll just write that out here. Embedded web application inside VS Code. That's the best way of thinking about it. So it's an embedded web application that's inside of VS Code. And whenever you're actually making API calls, or as an example, I'll show you like explain code, I think is one. Explain terminal, no, that's GitHub. I think like selection, or maybe GitLab. there's probably some duo chat commands. Maybe I have to have like an actual file open. Let me find one. And I select this, maybe, no, this is not gonna, might not watch anything. Explain, maybe. Yeah, so this GitLab Duo Chat explains selected code, right? So it's explaining this code and it's using the selected text, right? Just like this. So what's happening is this Duo Chat little web app, if you will, is talking back and forth with the extension. And remember that the extension is written in Node.js. So um, whenever you see the code in here, this is Node.js code, and this code is Vue code. So when you think of Duo Chat, like the UI, so we'll just put like maybe a little thing up here. Duo Chat UI, just think Vue and Duo Chat, backend, if you will, is a good way of explaining it, is written in Node.js. It's a little bit different in the JetBrains world, and Dylan can definitely explain a lot about that. But on the VS Code side of things, that's how it's written essentially. So we have the Duo Chat UI is written in Vue, and the backend is written in Node.js. And if you want to see where all the magic happens, I think it's called acquire. Acquire VS Code API. So what you'll need to do if you want to go into the Duo Chat, London already knows this, but in case you guys are curious, and on the Duo Chat side of things, if you go to, I think it's Vue 2 GitLab Duo Chat. So when you see this VS Code, acquire VS Code API, this is where the communication between the web app and Node.js or the runtime or the VS Code extension, all the same thing. That's where this communication part here happens, is that acquire WebView API. And definitely I encourage like going in and trying to build the extension if you want, and console logging some statements so you can see how all of this data flows around. But this is really how we made Duo Chat work inside of VS Code. It's roughly the same for like a lot of things. So like GitLab.com, instead of it talking with the extension on GitLab.com, it talks with the actual GitLab backend. So if we go like this, on GitLab.com, it's talking to, GitLab backend, which is written in Ruby on Rails. So yeah, but we can remove this for now in case that, confuses you guys. But any questions so far? I know it's a lot, but wanted to at least get through like how Duo Chat works, right? From the very bottom. So this is, if you understand this flow, you understand our tech stack, and how to like make changes and navigate and all that stuff. So I see Joshua is smiling. Do you have any questions?
No, I was just thinking like the chart got so big.
Yeah, yeah, it's definitely crazy looking, right?
Yeah.
Um, cool. London, do you have any questions? Victoria, Derek? Like, feel free to ask me anything. Seriously. Like, if nothing makes sense, please let me know. Because, like, um, knowing this stuff is super important and at being at GitLab. But I also think just in general. So there we go. And I'll send you, if you guys want a screenshot of this, I can send it to you if you guys like.
Yeah. Yeah.
Cool. I think we're at time. Dylan, did you have anything?
Nothing to add specifically. I will be transparent. I have never been taught the like browser server runtime thing. So that is the first time I've ever seen that diagram.
Oh, really? Wow.
Yeah. But I appreciate you explaining that because otherwise I would just be living in fantasy world over here, not knowing what it is.
Well, it's at the end of the day, all you have to know is that when you write code, there's always some developer, um, or super developer in this case, that's like taking your code and figuring out how to translate your code into machine code at the end of the day, right? Because what you're writing is an abstraction over some machine instructions, and that those machine instructions are actually an abstraction to translating to electrons, like making the CPU do work, right? And making your graphics processor actually, move electrons and stuff like that around the card. So it's like when you peel back the layers, and the more you do that, that's like my number one advice for anything, is the more you peel back the layers, the faster you can work with these higher level abstractions, because then you start to realize, like, all of this here, it seems complex, but when you realize at the end of the day, it's just JavaScript, and it just depends on how that JavaScript is executed and where it's executed, is like the pivotal thing of being able to, fly through all of these different technologies and how they talk together. So, yeah, welcome to my TED Talk. I don't know. If you guys have any other questions.
I have a question.
Yeah.
So, like you said, it is like kind of complex. It can get kind of complex. And the GitLab workflow is like its own extension, right? So like let's say you have a bunch of different extensions. How does the server not or whatever not like slow down, if that makes sense? Because a lot is going on at the same time, if that makes sense.
Yeah, that's a great, and that's also partly why VS Code is slow, right? That's a great question. So, when you often hear, like, in the industry, the more you get involved, you hear Electron. It's like, oh, it's written in Electron. Like, really? Like, Electron's so slow, right? Part of why it's slow is because it's not actually compiled bytecode or machine code. It's JavaScript that's being run through Node.js. So your question is, like, let's say you have 6 of these, right?
Yeah.
I'm not sure how it works. That's actually a good question. It's a good thing for me to probably learn. But when you have multiple extensions, so JavaScript, so Node.js, a little bit about how Node.js works, and I definitely encourage you guys to learn in depth how Node.js works. Node.js has this thing called the event loop, and so you can think of it as, like, you have a bunch of events that are happening all at once. And we'll do like API calls as an example. I'll show you how this relates to your question. So imagine you're calling, get user, which gets like user, right? Gets the user's details. And then also at the same time, you're fetching all the user's posts, right? As an example. And then imagine some other person is like making a totally different query, like, um, what's an example? Um, Maybe like adding a new post, right? So, and then every runtime is different, right? This is just how the Node.js runtime works, but this will hopefully answer your question a little bit. So, you have the Node.js server. Like we said, it's a server, right? So it's able to handle multiple requests at the same time, right? So you have these 3 things that are happening at the exact same time. So if you ever see the word async, this is where this kind of comes into play to a degree. So I want to get rid of this arrow. I don't know how to get rid of this arrow. Forget about the arrow. There's no direction. Like this isn't happening in sequential order. These are all happening at the same time. But what happens is this thing called the event loop. And it's literally a continuous loop. Just think of it just going like this, spinning around. And what it does is it goes and checks on, oh, okay, is this work done? Yes or no? It's not done, so let's skip over it. Is this work done? So have we gotten the user's posts? Oh, it is done. So let's send it off to, back to the user, right? So this gets done first, and then it gets sent off to the user that requests it, right? And then it checks, okay, is this done? No, it's not done yet. And then it does this, and it just keeps repeating over that. And this is a super oversimplification, but it does that and does it in a looping fashion, right? So the same thing actually roughly probably occurs for all the different extensions, right? So if there's 6 different extensions, when it's loading them up, it's doing it probably in an asynchronous fashion, and it's just waiting for each one of these callbacks to finish when it's, for example, loading up, right? It's checking on each one of these things, but they're not blocking, right? So like if the GitLab workflow extension is taking a while to load, it's not going to block the rest of the UI because it's loaded asynchronously, right? That's the name, the term for it. Does that help? Or you have any other questions?
Yeah, it makes sense. It makes sense.
But yeah, if you understand Node.js, like definitely spend some time learning how it works. It'll hopefully put together this side of things a little bit more. But yeah, that's basically it. That's all the time I have for you guys today. I'll send you probably a screenshot of this diagram, and I'll put the recording up in case you guys want to rewatch it or anything. And then if you want, you can schedule like a part 2, and we can, go over more questions if you guys want to look at the stuff and then come back with questions. But yeah, this is a little bit of a high level architecture of how these things work. Cool. All right. Well, I'll start recording. Where's the record? Oh, there it is.